Now let's take a look at how to configure OSPF. To configure OSPF for a single area, note here we're starting at the global configuration prompt, and we want to issue the command router OSPF, and then we'll use a special keyword here called the process ID. The process ID simply differentiates one OSPF process on your router from another OSPF process on the router. For instance, I mentioned before that you could have one router that's called the ASBR, the Autonomous System Boundary Router, and this router could be attached to another autonomous system where you're running another routing protocol like EIGRP, and then over here you're running OSPF. However, instead of running EIGRP over here, this could simply be another process of OSPF. And so, in order to differentiate on this router between the different processes of OSPF that are running, you would use this process ID. This process ID, you can just pick any number that you want. It doesn't have to coordinate with any particular IP addresses or anything like that. A lot of times we simplify it by just using OSPF process ID 1 and then OSPF process ID 10 or 100 or whatever. The important thing to note is that whatever process ID I'm using here on this router, if I'm going to exchange OSPF updates with another router, both routers would need the same process ID in order for communication to take place there. So you use that process ID. Once you've issued this command, router OSPF, and the process ID there, router OSPF 1, notice now the prompt changes to config-router. This is router configuration mode. This is a configuration mode to configure your routing protocol. Once you're in that configuration mode, you now want to indicate what networks you want OSPF to advertise or to gossip to other routers. Okay, so network is the command, network, and then you issue the address or the network address. You could say 10.1.1.0, and then you use a mask. The mask here that we want is called a wildcard mask. The wildcard mask is just the opposite of the subnet mask, just the opposite of the way the subnet mask works. Remember, with a subnet mask, all of your the 1 means match, and then 0 means ignore on a subnet mask. However, we reverse this with the wildcard mask, and now 0s mean match and 1s mean ignore. What I mean by that is this. With a 10.1.1.0 network address, these 3 octets we want to match perfectly. We want to advertise these octets, and then we ignore whatever is in the last octet. So we want to match the first 8 bits, match the next 8 bits, match the third octet here, and then ignore whatever bits are in the last octet there. So the wildcard mask would look like this for advertising this entire network. So this tells the router that this particular OSPF process is going to advertise network 10.1.1.0, advertise it to all other OSPF routers. So the wildcard mask that we would use here would be 0.0.0.255. And notice we're still on the same line, still going to be on the same line. I've just run out of space here. On that same line, you want to indicate the area that this network is in, or the interface wherever this network is. You want to indicate which area that interface is in. So area 0 here. Let me show you what we're doing here. This router has an interface serial 0 here, and that interface is in area 0. This router has another interface that we're going to say is in, I'm going to say this other interface here is actually in another area, area 1. Interface serial 0 has an IP address of 10.1.1.1, and then this other area over here, this other interface, will give it 172.16.1.1. Because this is the network address on the serial interface, in order to indicate to OSPF what area this particular interface is in, I give the network command indicating the network that's on that interface and indicate the area with that network. This tells OSPF that this interface is in area 0. And that's single area OSPF. However, if I want to do multi-area OSPF, area 0 and then area 1, this other interface over here, serial 1, S1, with 172.16.1.1 IP address, would be configured. We'll add another line here. This interface would be configured with network statement 172.16.1.0, and the wildcard mask, we'll use the same wildcard mask. This time, though, we'll indicate area 1. This puts the serial 0 interface in area 0, and then the second line puts the serial 1 interface in area 1. So this is multi-area OSPF. If you had single area OSPF where both of these interfaces were in area 0, that 172.16.1.1, we would then have both of those statements indicating area 0. So the area flag here, that area command, indicates the area that that particular interface is operating in with OSPF. Now, to verify your OSPF configuration, you have a couple of commands that you can use to verify. You can use the show IP protocols command. This is going to show you all of the routing protocols that are configured on your router and certain parameters about those different routing protocols, such as update frequencies, such as networks that they're advertising, such as the gateways or other routers that they're communicating with using that particular routing protocol. So that's show IP protocols. That's for verifying any of your routing protocols. Show IP route, of course, shows us our routing table. That routing table, remember, will have certain codes at the beginning of that table, at the beginning of each network line, indicating where the route or where that network was learned from. So in the routing table, if you see any O's, that would indicate that that particular network line was learned by way of the OSPF process. Another command would be show IP OSPF interface. This shows the OSPF interfaces, or the interfaces that are configured to advertise OSPF networks. And then show IP OSPF neighbor. This shows us the neighbor table, the table of neighboring routers that are using OSPF and that are exchanging OSPF updates. That's the OSPF neighbor table. There's also one other command, show IP OSPF database. This shows the topology table. OSPF builds a topology of the entire network with the router that you're on as the root, so to speak, or the reference point for the whole network. And so it then builds a shortest path first tree, or the fastest path to each different network throughout your company's network, so that OSPF can then make the best choice between the different paths to any given network. And you can see that topology table with the show IP OSPF database command. So that's a brief look at how to configure single area and multi-area OSPF, as well as how to verify your OSPF configuration.